Hi, I'm Andy Evans from TerraView. Going to present the use case on smart viticulture and the demonstration of it. So quickly, what is TerraView, or who is TerraView? TerraView OS. TerraView OS is a decision support system for viticulture, so for growing grapes and on the vine. It's run on the cloud and is centrally deployed. Traditionally, it's architected as a microservices stack with many moving parts. Essentially, those moving parts are the individual services, and we have approximately 54 pods running on Kubernetes. Should you wish to see more information about what TerraView is and the product itself, you can see at terraview.gmbh. So for our demonstration today, we have a brief demonstration. The demonstration is where a producer employs the services of a drone operator. That producer naturally is an owner of land. That land produces grapes for the creation and production of wine. The drone operator, in this case, has completed their survey of a part of that vineyard of 14 hectares area in size, and now the drone operator supplies the content of their surveys. So what they do here is they plug the SD card that they've taken from their drone and insert it into a USB adapter, which then is taken and inserted into the edge device that is out on premise. The edge device then processes that imagery by copying the imagery from the USB device over onto the edge device where it begins to process it. And once done, the processed imagery is then made available to the producer via UI after it's been transferred across when the network is available. So the system, or at least the user interface before the drone survey is done, the imagery is of low resolution provided by an image provider, so we can see that here. So here you can see the low resolution, and it's not particularly useful in our case. Now, for this particular survey, the only thing that we're doing is taking optical imagery, but that imagery that we have taken can also be used for other purposes. So, for example, the calculation of agricultural and agronomic indices that are used for understanding how well the crop is behaving and acting for the particular time of the season. If we go back now, and after we have done the demonstration, the system that we have is then higher resolution, much higher resolution. In fact, probably most likely at a ground sampling distance of 4 centimeters. We can have a quick look at the system itself. And here you can hopefully see a higher resolution itself. And by having a higher resolution allows us to calculate better and more fine-grained agronomical indices like NDVI. Now if we just move on into the slides, this is the demonstration stack. Now in FLUIDOS we have a huge amount of deployment flexibility. For our particular case, we've selected the following configuration. Configuration on the producer side, that being the edge side, we have it on here on the left hand side. So we have naturally all the FLUIDOS software built upon Liquo. Then on that we have Kubernetes, which is a K3S, and we have our general purpose operating system, which is simply a Linux distribution. It's Ubuntu. And then we have our commercial off-the-shelf server, which is the actual edge hardware. We'll see an image of that later on. On the consumer side, we have FLUIDOS again, Liquo, but this is actually sitting on top of an enterprise managed Kubernetes service, and this is provided in our particular case from Google. So the demonstration itself, this is the architecture itself. So if we look into it a little bit more detail, we have all of TerraView OS here, as you see on the right-hand side with our, as I said, approximate 54 pods. And there we also have the Helm. We have Helm, and Helm is used for deployment along with the intents. We have the FLUIDOS software then, one level beneath. And here we have Liquo, the node software, and the meta orchestrator. The meta orchestrator takes Helm and the intent as inputs in order to carry out the complete deployment. On the consumer side, we have our Kubernetes cluster. sitting on top of our Google Managed Service. And on the left-hand side, we have our K3S cluster, which is the producer itself. So if we have a look at the producer, we'll be able to see what we have there at the moment. Here you'll see some namespaces. Namespaces of interest to us right now are the FLUIDOS and the Liquo. And you'll see that there is no running image processing or anything like that. This is just the bare bones FLUIDOS setup upon Kubernetes. If we have a look on our consumer side, we will see everything pretty much similar, except we'll see a lot more pods, given that we have all of the TerraView OS pods running. There you'll see inside of the default namespace, we have at the very top, we have some, not all, some of the pods. So here you see traceability, which is a component of TerraView OS. We have VineClick, we have weather. These are all TerraView OS. And then we start to see familiar things. So we have the FLUIDOS namespace, Kubernetes is there, and then Liquo is also. And right here then at the bottom, you'll be able to see the pod ODM processing. And that's the pod that's responsible for image processing. And it's true intent that we'll be able to move that workload across when it is required to be there. So we jump on to the next slide. So the next part of this demonstration is one that we have the intent definition, and then we will show once the intent is supplied to the system, what happens at runtime. So essentially at runtime, what will happen is that it'll pick up the image processing pod and move it across onto the edge node itself. So we have a look firstly at the intent itself. This is the intent. Wonderful thing about this intent is that it's all Kubernetes in its syntax. There are extensions, and the main extension here is in the metadata, which if if the particular deployment of Kubernetes didn't understand or wasn't deployed with FLUIDOS support software, then it was free to ignore it. Then we have the annotations that specify that, look, this needs to be run on the edge itself. So if we then go to the runtime, once that intent is supplied to the meta orchestrator, this is what we'll see. There's a lot of text here, granted, but I think what's important here to call out is the annotations, and these are the intents. And then if we go on down to the bottom, well, as we look down through it, we will see that the intent is activating the migration or the movement of the workload across. And this is it. This is where the connection to the remote node is made, and the workload is fluidly moved across. Then if we look at the edge cluster, after the meta orchestrator is executed, we'll see this, and here on the edge node now, see TV Edge 01, we'll see our ODM processing software here. That's the image processing itself. Okay. So once that image processing is available on the edge itself, now the drone operator comes along and inserts their USB key into the edge device. So down here, this is the edge device that we use. On top of that edge device, you'll see the USB key itself, and in that USB key is the SD card that's been taken from the drone itself. Once inserted, the processing will then begin. So if we look up here at the image processing pod itself, this is the tvOS image processing itself. That's already been moved across from the meta orchestrator. And here you'll be able to see then the ODM processing software there up and running. Now, as it's running, it takes approximately, well, this is dependent on the size of the survey done. The surveys that we're most familiar with and what we see in everyday operation and use inside of TerraView OS normally takes maybe perhaps 8 hours, especially for large areas. For this demo, given that it's relatively small, The demonstration itself takes about 40 to 45 minutes. Not the demonstration, sorry, the processing takes approximately 40 to 45 minutes. And that processing will happen. So we can have a quick look and see what we would typically see also. So here you'll see the processing, and the processing is using particular images in order to, one, take all the various images and stitch them all together in what's known as an orthomosaic. And with an orthomosaic, then we can do various things. One, we can carry out our operations in terms of agricultural agronomic indices, but also we can tile it. And by tiling it, makes it suitable and ready for display in a regular web browser. It's typically what we would see in Google Maps, for example. That's what it uses itself to display maps. And you see the continued processing of it. And eventually it's complete. And once it's complete, the output of that is copied across back into TerraView OS. TerraView OS simply uses NFS. And so we're running NFS over VPN in this case in order to make it secure, and so therefore make the copy complete. So we move on now to the next. So once, as I said, the imagery is processed, sent across to TerraView OS and made available to the particular tenant, the actual customer that is using the front end. And once they are able to get access to the front end, they'll be able to view this, and so then here we'll be able to see, as an end user perspective, newly processed images available in the user interface. And we're back here again. So yet again, we're here. The new high resolution imagery is ready for the end user. And that's the end of the quick demonstration. And thanks for your attention.